Hello everyone, and welcome. I'm excited to introduce you to today's presentation on Reasoning Classes, Part 3, focusing on advanced topics. I'm thrilled to have you here as we delve into more complex reasoning concepts. The book is written by Varun Vijay, and it's specially designed for those preparing for exams like SSC, Bank, Railway, BPSC, and UPSC. Today, we'll explore how to master logic-based questions with clarity and practice. So, let's get started and make this session both engaging and informative. Let's take a quick look at the summary of what we've covered so far. We'll start with the syllogism or statement conclusion method, which is a fundamental reasoning technique. Then, we'll move on to understanding how to interpret a calendar and a clock, both of which are common in reasoning questions. We'll also explore puzzle and mixed reasoning types, which help us develop analytical thinking. The main goal here is to learn the core concepts, apply useful tricks, and practice solving questions similar to those in exams. This way, we build confidence and improve our problem-solving speed. Remember, this content is brought to you by the book writer, Varun Vijay, who's dedicated to guiding you through these reasoning skills effectively. Let's explore the core structure of logical statements. Every statement we analyze has two parts: the statement itself and the conclusion it leads to. Understanding this division helps us see the flow of reasoning more clearly. To visualize this, drawing Venn diagrams can be incredibly helpful because they make the logic visually intuitive. Now here's a trick to remember. When we say all, it indicates a 100% overlap. Everything in one set is included in another. When we say some, it suggests a partial overlap. Only part of one set intersects with another. And when we say no, it means there's no common part at all. Recognizing these keywords, all, some, no, and some not, sets the foundation for understanding the relationships between different statements. This approach is crucial because it simplifies complex logical relationships into clear, visual concepts. And by mastering this, you'll strengthen your ability to analyze arguments logically and make sense of the reasoning process. Remember, these tools and tricks are part of building a solid logical framework, which aligns with our overall goal of sharpening critical thinking skills. Let's now look at how syllogisms, statements, conclusions, and examples come together. On this slide, we'll explore the structure of logical reasoning through an example and some practice questions. First, the example says, all pens are books, some books are papers. From these, only the conclusion that only conclusion I may follow. This highlights how we analyze the relationships between different statements to determine what conclusions are valid. Now, moving to practice, we have a few more scenarios to test our understanding. The first one is, all A are B, and all B are C. The question is, does some C are A? Think about the chain of relationships here. It helps us see how conclusions can be drawn or not. The second practice question is, no dog is a cat, and some cats are rats. The question asks if some rats are not dogs. Again, we're examining how the premises can lead us to certain conclusions about the categories involved. Finally, the third question, some boys are girls, and all girls are students. The question is, are some boys students? Here, we're exploring how the relationships between groups can imply certain overlaps. As you can see, understanding syllogisms and how statements connect is crucial for logical reasoning. This practice helps sharpen your ability to analyze and evaluate logical arguments, which is a core part of the overall theme of building strong reasoning skills. Let's talk about the calendar reasoning concept and a useful trick to simplify calculations. The key idea here is the odd days concept, which focuses on days beyond complete weeks. Essentially, when we count days, we're interested in how many days spill over after accounting for full weeks. For example, 1 week has 0 odd days because it completes exactly 7 days. Similarly, 1 year has 1 odd day, and 100 years total up to 5 odd days. Now, to make calculations easier, we use a formula that combines several components: the number of years, leap years, the date, the month code, and the century code. All of these, when summed up, are then divided by 7, and we look at the remainder. That remainder gives us the odd days, which helps us determine the day of the week efficiently. This trick is powerful because it simplifies what could be a complicated calculation into a straightforward arithmetic operation. Remember, understanding the odd days concept is fundamental to mastering calendar calculations, and this formula encapsulates that neatly. It's a clever way to connect all these elements and quickly find the weekday for any given date. Let's look at calendar reasoning with an example and some practice questions. For the example, we want to find out what day of the week was August 15th, 1947, and the answer is Friday. It's a good example because it shows how we can determine specific days in history using logical reasoning. Now on to the practice questions. First, what day was January 26th, 1950? Think about how we can approach this by counting days from a known reference date or using patterns in the calendar. Second, if January 1st, 2025 is a Wednesday, then what day will January 1st, 2026 be? This helps us understand how the calendar shifts from year to year, especially considering leap years. And third, which year has the same calendar as 2011? This question encourages us to look at the recurring patterns in calendars, where certain years repeat the same layout of days and dates. This kind of reasoning is fundamental because it helps us quickly figure out days of the week for any date, which is very useful in many real-life situations. Remember, mastering this skill connects directly to our overall goal of improving our understanding and calculation of dates and calendars. And this content was brought to you by Varun Vijay. Now let's look at the concept of clock reasoning, which is both interesting and very useful for solving clock-related problems. The key idea here is to understand how to calculate the angle between the hour and minute hands at any given time. The formula we use is the angle between the hands equals the absolute value of 30 times the hour minus 11 2 times the minutes. What does this mean? Well, the term 30 times the hour represents how far the hour hand has moved from 12 o'clock, since each hour corresponds to 30 degrees. The second part, 11 2 times the minutes, captures the movement of the minute hand and how it influences the angle. Here's a handy trick to remember. 1 hour equals 30 degrees, and 1 minute equals 6 degrees. When the hands coincide, the angle difference is 0 degrees, meaning they are together. When they are opposite each other, the difference is 180 degrees. This approach simplifies what might seem complicated at first glance and helps us quickly determine the angle at any time. Remember, Varun Vijay, the book's author, emphasizes these concepts because mastering them is essential for tackling clock problems efficiently. So, keep these points in mind, and you'll find solving these types of questions much easier. All right, let's dive into some clock reasoning with an example and then practice together. On this slide, we see an example, finding the angle between the clock hands at 3:15. The answer is 7.5 degrees, which is correct. This example shows how we can approach such problems by understanding the positions of the hour and minute hands at a given time. Now, for the practice part, I want you to try solving these 3 questions. First, find the angle between the hands at 4:20. Think about how far each hand has moved from the 12 o'clock position and calculate the difference. Second, consider, when are the hands together between 2 and 3 o'clock? This is about understanding how the hands overlap and at what exact time this occurs. Third, think about when the hands are exactly 180 degrees apart between 6 and 7. This will involve calculating when they are on opposite sides of the clock face. These exercises are great for strengthening your understanding of clock angles and reasoning. Remember, the key is to understand how the hands move relative to each other and to the clock face. This approach ties back to the overall theme of problem-solving and logical reasoning in everyday contexts. All right, let's dive into puzzle and mixed reasoning, focusing on the concept and the trick behind solving these types of problems. When dealing with arrangement puzzles, I find that using a table or grid is incredibly helpful. It allows you to organize the known data clearly and see what possibilities remain. The first step is to write down all the known information up front. This sets a solid foundation. Then, you systematically eliminate impossible cases, anything that contradicts the known facts. This process narrows down the options and makes solving much more manageable. Now, here's the trick that often makes the difference. Solve one condition at a time. Instead of trying to tackle everything all at once, focus on one piece of information or one rule, apply it fully, and then move on to the next. This step-by-step approach reduces confusion and helps you build a logical chain toward the solution. Remember, these techniques are not just about getting the right answer. They're about developing a clear, methodical way of thinking. By organizing data carefully and applying conditions one by one, you'll find that even complex puzzles become much more approachable. This strategic approach ties back into the overall theme of logical reasoning, which is at the heart of solving reasoning puzzles effectively. Let's look at the example on this slide to understand puzzle and mixed reasoning better. We have 4 persons, A, B, C, and D, who are on floors 1 through 4. From the clues, B is above D is not on the top floor and C is below B, so when we arrange them, C ends up on the first floor, D on the second, B on the third, and on the fourth. This example shows how we can logically deduce positions based on given conditions. Now, moving on to practice, we have 3 different scenarios to work through. First, 5 friends living in 5 different colored houses. Here, you'll create a relation chart that helps visualize and logically connect the clues. Second, 4 students reading 4 different subjects. Your task is to assign each student a subject logically, ensuring all clues fit together. And third, 3 brothers, A, B, and C. Each has a different profession. 1 doctor, 1 teacher, and 1 engineer. You need to figure out who is what based on the clues provided. These exercises are designed to sharpen your logical reasoning and help you approach complex puzzles methodically. Remember, the key is to analyze each clue carefully and build your deductions step by step. Let's do a quick mini revision of some key problem-solving techniques. First up, syllogisms. Remember, drawing Venn diagrams is incredibly helpful here. It allows us to visualize the relationships between different sets and quickly identify the correct conclusion. Next, the calendar method. To master calendar-based questions, focus on remembering the odd days. That way, you can easily determine the day of the week for any given date, which saves time and reduces mistakes. Moving on to clocks. There's a handy formula, 30 hours minus 11 2 minutes. This helps us quickly find the time difference or calculate the time after a certain period, especially when dealing with clock problems. Then, puzzles. For these, always start by drawing a table and filling in the confirmed data first. This approach organizes information clearly and helps you see the connections more easily, making the puzzle less intimidating. And as a final motivational note, remember that practice really converts logic into instinct. As Varun Vijay said, consistent practice helps your reasoning become second nature. Varun Vijay is also the author of this book, which offers many such insights. Keep practicing these techniques, and you'll see your problem-solving skills improve steadily. Thank you all for being such attentive listeners throughout this series. This slide wraps up the entire full reasoning series, from Part 1 to Part 3. We've covered a lot, starting with the basics of the alphabet and progressing to more complex concepts like syllogisms, along with helpful tricks and examples to simplify them. The key takeaway is the importance of consistent practice and staying confident in your reasoning skills. Remember, reasoning is a skill that improves with effort and perseverance. I encourage you to keep practicing regularly and believe in your abilities. This is Varun Vijay, the author of these books and your guide for reasoning classes aimed at cracking competitive exams. Thank you once again for your dedication and attention. Keep pushing forward, and all the best in your preparation.